In today's lesson, we're going to be looking at ionic and covalent bonds again, and this time we're going to be comparing and contrasting them. So previously we looked at what ionic, covalent, and metallic bonds were, and this time you're going to have to complete a comparison, a Venn diagram basically, between ionic and covalent compounds. You'll see over here we've got an example of an ionic compound where the electron is transferred from the metal to the non-metal, and down here we have an example of a covalent bond that's formed when two nonmetals share their electrons. Our learning intention for today is to compare and contrast ionic and covalent compounds based on the elements found in them, the way they are formed, and their properties. You need to write your learning intention on the output page only, please, as you're only going to do the Venn diagram. The rest of it we've already taken as notes. So for our success criteria, you need to be able to compare and contrast the types of elements that are in an ionic and covalent bond. So is it metals? Is it nonmetals? Is it metalloids? You need to compare and contrast what happens to the electrons in an ionic and covalent bond. Are they shared? Are they transferred? Compare and contrast the properties of an ionic and covalent bond. Okay, and then you need to show that in a Venn diagram or some other form of graphic organizer. As a chemical bonding review, remember the whole reason that atoms are going to bond is because they're trying to get a full outer shell. So group 18 in the periodic table already has a full outer shell. We don't need to have them bonding. So they've already got 8 electrons in their outer shell and they're happy. Okay? Other atoms though, so groups 1 through 17 are not happy because they don't have a full valence shell. Okay? They're considered to be unstable and reactive. With that, they're either trying to gain, lose, or share an electron to achieve stability. Remember, there are 2 different types of bonds that we were looking at. There are 3, but we're going to focus mostly on ionic and covalent for the rest of the unit. So an ionic bond is formed when electrons are transferred. So you have a metal that's going to give its electron to a nonmetal. Okay, when this happens, the metal is going to have more positive charges than negative, so more protons than electrons, and becomes positively charged. The nonmetal has more electrons than protons and becomes negatively charged, and they get attracted to each other. Remember, opposites attract. Okay, like I said, this only happens between metals and nonmetals. Examples of metals, we have lithium, sodium, magnesium. Examples of nonmetals, oxygen, nitrogen, carbon. If you're struggling with where to find metals and nonmetals on the periodic table, do please come to see your teacher. Okay, the other type of bond is a covalent bond, and this happens when you have 2 nonmetals. Okay, neither one is stronger than the other, so neither one can actually take the electron from the other. So they end up just sharing their electrons together to achieve a full valence shell. The whole reason that the atoms are doing this is because they are trying to achieve the octet rule. They are trying to get 8 electrons in their valence shell because 8 is the magic number. 8 is great. Okay, it's the magic number that keeps them stable. Of course, we have 2 exceptions for that, which is hydrogen and helium. Couple of examples for you. So this is a lithium atom here. You can see it has 3 protons and 3 electrons. Lithium is unstable because it only has 1 electron in its valence shell. It would like to either have 8 or it would like to actually get rid of that shell completely and go down to the next shell below it, which is full. For lithium, what do you think lithium will do? It has 2 choices. It can either get rid of 1 electron or it can go find 7 more electrons. Lithium is going to do whatever is easiest. So if it requires less energy to get rid of 1 electron, that's what it's going to do. If it requires less energy to get 7 more electrons, then that's what it will do. In this case, lithium is a metal, and what it's going to do is it's going to get rid of its 1 electron to go down to the lower shell, the next shell lower, that is full. Okay, lithium now has 3 positives and only 2 negatives. So what would be the charge on lithium? If you answered +1, you're correct. Okay, next slide, we have an example with the oxygen atom. In oxygen, we've got a full valence shell, or a full shell in the middle, and then only 6 electrons in the valence shell. Oxygen has 2 choices again as well. It can either go and find 2 more electrons, or it can get rid of all 6. So it's going to do what is easiest, and that is to find 2 more electrons, to then have a full valence shell of 8. Total number of electrons here is 10. Total number of protons is 8. That would give oxygen a 2 negative charge. Don't forget, oxygen will become an anion, a negative ion, whereas lithium will become a positive ion. All right, so you can see that we have the oxygen ion. Now what you need to do is you need to use your doodle notes, and you need to create a Venn diagram to compare and contrast ionic and covalent bonds. If you would like a challenge, you can add a 3rd circle in there down at the bottom, and you can add metallic bonds to compare as well, but that is not required. Once you've finished your Venn diagram, you need to show your teacher to get it checked. If you need a little more help, you can watch these videos on ionic bonding or on what ions are. I'll also add a few more slides in to just review cations and anions. Possibly in the next video, though, that might happen. Okay, or you can check some of these extensions here. The extension is this interactive where you can form different ionic bonds, or you can check chemical bonding and some videos on ionic bonding specifically for yourself.